Okay guys, we're talking about systems of equations, systems of linear equations. So only straight lines are being drawn and we're looking for an intersection point or a common solution. Since each line that we draw is an infinite number of solutions to that equation, the place where the two lines overlap is the common solution that we're looking for. Okay, so if you look off to the left, you're gonna see what we're gonna be doing this week. Now we did a little bit of work today with graphing, and we're gonna take a couple more looks at examples using the graphing method, but it's the least efficient method. It's only as accurate as your graph. So while you were doing things today on IXL made everything pinpointed perfect. What I'm gonna be doing here is gonna look a little bit messy, but I'm gonna try and get you to visually see what we're gonna be encountering. Now, substitution is the next method that we're gonna do. We're gonna introduce that on Wednesday, and we'll take a look at these same examples again using substitution method. Finally, on Friday, we're going to take a look at my favorite method, elimination, and we're going to build off of elimination and do not only 2 equations in 2 variables, but 3 equations in 3 variables. Okay? Now, let's take a look at our first example. Right now, we have two equations in 2 variables, and they're in standard form of the equation. I know that's not your favorite form of the equation, but it's the best form for when we get into the elimination method, which again is going to be my favorite, and I think you'll, when it clicks for you, it'll eventually be your favorite as well. Now, the best form of this equation is going to be in slope-intercept form to take a look at the graph. So I'm going to rearrange number 1, which is x plus y equals 1. So the first thing I would do is I would subtract x from both sides. And when it gets into y-intercept form, it's y equals negative x plus 1. Okay, now if I were to rearrange this, a cheat here, I would actually subtract the 5 and add the y. Subtract the 5 and add the y. And we're going to get positive y is equal to 2x minus 5. I'm sorry I don't have room to prove that out, but do this on a piece of scrap paper, and trust me, you should end up with y equals 2x minus 5. Now, these 2 lines, when I'm taking a look in slope-intercept form, they have different slopes. One is -1, the other is positive 2x. As long as 2 lines have different slopes, they will eventually, on a large enough graph, meet at a single point, okay? So when you meet at a single point and you have a solution, it's what we call consistent independent, and I'll get to those terms in another video. But we'll start by graphing the first one, which has a y-intercept at positive 1. Okay, so we'll draw a point there, and it has a slope of negative 1. So down 1 over 1, down 1 over 1. We'd get a few points, and we'd have a straight edge, and we would plot the line. And again, my answer is only as accurate as my drawing. This is not very accurate, so I wouldn't be 100% certain of the solution. I know what the solution is already, so we'll work backwards from there. Now over here, we get to the second equation. We have a y-intercept of -5, down 1, 2, 3, 4, 5. We'd go up 2 over 1 and up 2 over 1. Continue, we'd go up 2 over 1. And we draw a straight line, and you can see that the point that they meet is the point of intersection or the common solution. Now, on my graph, it would be 2 to the right and 1 down. So 2, -1 would be the solution to that equation. Okay, now I can be more comfortable with the answer if I was using one of the other methods like substitution or elimination, because that just requires me to do algebra, and my algebra is much better than my artistic ability. Okay, so that is going to be our one solution right here, and I'll come back in the next video and we'll talk about a no solution case.